All right, this week we're talking about acquired immunity, which involves these cells called lymphocytes. And this is not the, hey, you don't belong here. I don't know who you are, but I'm going to kill you because you don't belong kind of immunity. This is very specific. We're looking for a very specific type of bacteria, specific type of virus, and that's the only thing that these cells kill. So there are two types of your lymphocytes. You have B cells and T cells. B cells, which mature in the bone marrow, um, are responsible for what's called your humoral immunity, which is basically the fluids of your body, your blood, your the liquid in between your cells, those kind of things. And the way they work, they don't actually come up to, they don't connect with the pathogen, the bacteria, the virus. They release these little Y-shaped proteins called antibodies that they release from the cell, and then those antibodies stick to the pathogen. And these antibodies have a very specific shape for the receptor that's going to stick to the antigens on the bacteria or the virus. And antibodies can do four things. First, they can block the binding sites of viruses or bacteria so that they can't stick to a cell and inject their DNA or release proteins that are going to start to digest the cells or whatever those pathogens are doing. So they can block the binding sites. Second, they cause agglutination, which is basically clumping. If you think about in the old days, prisoners used to go in on what's called a chain gang, where everyone's legs would be kind of tied together or bound together by bars. And so one of them couldn't run away without all of them running away. And no one can run away fast if you're connected to all the other people. Well, that's kind of the idea here. These Y-shaped antibodies will stick to one cell and they'll also stick to another cell. And that cell is sticking to a different cell, which is sticking to another cell. And so your phagocytes can find this clump and easily just come and digest the whole thing. And then also antibodies serve to activate other components of your immune system, such as your complement proteins, which cause a cell to pop, an infected cell to pop, or your natural killer cells, which also cause your cells to pop. All right. So those were B cells. They release the antibodies. Your T cells mature in the thymus gland, T cell, and they do cell-mediated immunity. They get their hands dirty. They will go to the infected cell and bind to it and release a chemical that's going to kill that cell. And that chemical is called perforin, like to perforate, to poke holes in. So it literally just pops the infected cell. And there's two types of T cells. Helper T cells are going to activate your cytotoxic T cells, which are the killer cells. They're the ones that do the popping. But helper T cells will also activate your B cells, which are releasing the antibodies. Now, the helper T cells know what they're looking for because of dendritic cells, which hopefully you remember from last week. They're a type of phagocyte that is going to eat pathogens, but when it digests them, instead of just getting rid of the pieces, it's going to present those pieces to the helper T cells. And that's going to activate them to divide, and it's going to stimulate them to cause more killer T cells and more B cells. And so all of this takes a little bit of time. So when you're first exposed to a pathogen, it can take up to 3 weeks for you to beat it. That's what's called your primary response. And so that's the time it takes to develop all of these cells and for them to fight it and for your symptoms to go away. But once you've fought a specific type of pathogen, next you make what are called memory cells. And these are B cells and T cells that will just kind of hang out in your lymph nodes. They'll hang out, in your thymus or your bones, and they'll live for a long time. And if you're ever infected again, they're ready to rapidly reproduce, and you get a much greater response